On this first chapter of Pure Math 3, we're going to learn a little bit more about polynomials, and you are going to learn a completely new function that turns everything that is negative into positive. Let's start with the polynomials. What is a polynomial? You know this for a long time. A polynomial is an expression of this kind, in which you have different terms, and each term has a different power. The order of the polynomial is the order of the highest power. So for example, if you have the highest power as being ax to the power of 3, that is going to correspond to a cubic. If n equals 2, then it is a quadratic. Quadratics is the polynomials is a polynomial that you studied a lot last year in Pure Math 1. So this can go indefinitely up, but here you are going to study no more than order 5. There's a lot you can do with polynomials already. You know how to add and subtract polynomials. You've learned this a long time ago. So let's look into it a little bit. Let's say that you have these two polynomials, both of order 4, so they are both quartics. And if you want to add them, what do you have to do? You have to look at the terms with the same power, and you just add or subtract with them. So in this case, the 5x to the power of 4 adds just to the 7x to the power of 4. The 3x to the power of 3, you make the operation with the 5x to the power of 3 on this side, and so forth. And you end up with this one. What about multiplication? In multiplication, now you have to deal with all the terms in each of the polynomials. Here you have them again, and here you have to, for each term in one polynomial, you have to multiply all the terms in the other polynomial. You will get a huge expression. And then you have to, again, follow the rules that we just seen over here. You have to add just like terms, eventually ending up with a polynomial, in this case of order 8. And everything that you learned so far in terms of operations with polynomials ends here. If you think of it, you never learn how to divide polynomials. So that's what we're going to look into on this chapter. And you'll have to be reminded of something that you learned a long time ago and probably never used again. I'm talking about long division. Remember that? So how do you divide polynomials? You just use arithmetic long division. Let's see how this works. Let's say that we want to divide this polynomial over here by that one over there. So this one is a dividend, and that one is a divisor. What do you have to do? Remember this? You put the dividend, you write it down. You put this line, it looks like a square root, but it's not the square root. It's just this line, just to divide the different parts of what you already have and what you are going to have. So again, the dividend over here, the divisor over here, and then you are ready to start doing the long division. What you have to look at? You have to look at the highest term of the dividend and the highest term of the divisor. And then you just do one very simple thing. You divide this by that. So in this case, if you have 2x to the power of 4 divided by x squared, what do you end up with? You end up with that, 2x squared. What do you do next? You multiply this by the whole thing again, the whole divisor again, and write it down over here. Now pay attention to one thing that I highlighted here on this with this green box. It's very important for you not to make mistakes. It's very important that you put all the terms with the same power aligned in columns. See, here you have a dividend that has all the powers from x to the power of 4 until x to the power of 0. That's this one over here. X to the power of 0 is 1, so you don't even write it, right? So you have x to the power of 4, x to the power of 3, to the power of 2, to the power of 1, and to the power of 0. But when you multiply 2x squared by this one, this is what you'll get. 2x to the power of 4 plus 2x squared. So you don't have anything with x to the power of 3, but you still need to write it underneath the column corresponding to the x to the power of 3's. Otherwise, the calculations, when you start doing them, they may be wrong. This is very important. So you either leave this blank or you just write the zero coefficient and then x to the power of whatever term, and you leave it there. So in this case, I did it like this, and then what do you have to do? You have to start subtracting, and you subtract 2x to the power of 4 to 2x to the power of 4. It is supposed to be 0, so you don't even write it. And then you do the same thing over here. So 2x to the power of 3 minus nothing is 2x to the power of 3. And 5x squared minus 2x squared is 3x squared. You write it here. And then you will need to bring this one down. You're going to see why later. Once you have done this, you have to repeat the whole process again. Now your highest term over here is 2x cubed, so you divide by 2x squared. 2x cubed divided by 2x squared is what? 2x cubed divided by x squared is going to be what? Is going to be 2x, and that's what you write over there. So again, you divide this by this, and you write the result over there. 2x cubed divided by x squared is 2x. And then you repeat the procedure. 2x times all that stuff, you'll get 2x cubed plus, again, 0x squared for the same reason I mentioned before, plus 2x. You write the whole thing over here and then subtract again. The result is going to be this over here. 3x squared plus 0x plus 3. This is going to be the same order as the divisor, so you can still divide it. So 3x squared divided by x squared is just 3. So you now multiply again. You'll have exactly the same polynomial that you got over there. You subtract it and you have remainder 0. What conclusion do we get? We know now that dividing this polynomial by that one, the result will be this quadratic polynomial over here. Okay, simple enough. The procedure is very simple. I urge you to practice with exercises. Again, this is math. It's the only thing that you will learn, the only way that you will learn. But the procedure is ultimately very simple. It's just this. In this case, as you can see, you have no remainder, but you may have divisions of polynomials in which you do have remainder. And actually, this is going to be important later on, as we're going to see. Let's now look at one very important theorem that is going to be required to answer a certain category of questions. Let's look at something that you know for a long time, quadratics. We know for a long time that in order through polynomial, a quadratic, like this one, 6x squared plus 11x plus 4, may be factorized into something like this. This exact quadratic is factorized into these two factors over here. What does this mean? This means that if you find the value of x for each one of these factors is 0, then that value is going to be a 0 of the quadratic. You've learned this and you practiced with this extensively last year. So if you equal this to 0, what is the result of that equation? X is going to be minus 1/2. If you equal this to 0, the result of that equation is going to be x equals minus 4/3. This means what? This means that if you substitute x on the polynomial by either minus 1/2 or minus 4/3, the result of this is going to be 0, right? That's what I have over here. This means that if x equals minus 1/2 or x equals minus 4/3, these are the roots of the equation 6x squared plus 11x plus 4 equals 0, which is the same to say that substituting minus 1/2 on the polynomial is going to be 0, and minus 4/3 is also going to be 0. This can be generalized to every single polynomial, not just for quadratics, but for every single polynomial. And the generalization is this. if you can find, or if you know one factor of whatever polynomial, then if you equal the expression that factor is to 0 and you find the corresponding value of x, you will definitely know that substituting that value of x on the polynomial is going to yield 0 for the polynomial. It makes sense, right? You just found a factor of the polynomial, and by definition, the 0 of that factor will 0 the whole polynomial because it is a factor and is going to multiply by whatever else you have there. This is the factor theorem. If ax minus b, whatever this is a factor of a polynomial p of x, whatever that is, then the result of equaling this to 0, so in this case is b over a, substituted on the polynomial is going to yield 0. And b over a is the root of the equation px equals 0. Mathematically, you can write it like this. If p of b over a, whatever it is, equals 0, then substituting this into the factor, the coefficients, is going to be a factor of p of x. If you can find a value for which the polynomial equals 0, then you can automatically work back and get automatically one factor of the polynomial. Let's see an example. Let's say that for whatever polynomial, you know that p of 2 equals 0. So you know automatically that x minus 2 is going to be a factor of that polynomial. Let's look into something that may seem obvious to you. If you have, for example, this division, you want to divide 8 by 3. Okay, so what do? The maximum number of times you can divide 8 by 3 is 2. So 2 times 3 is 6. You subtract this and you get 2, right? So how can you write all of these things? I'm talking about the divisor, the dividend, the quotient, and the remainder. You can write it like this. The dividend, that is the 8, can be written as the divisor, that is 3, times the quotient, the result of the calculation, plus the remainder over here. 8 equals 3 times 2 plus 2. This is true for whatever division you are taking. The dividend is always equal to the divisor times the quotient plus the remainder. Here you have an example of two polynomials being divided. So again, you have here the dividend, the divisor, performing the algorithm that I just explained before. This is the quotient that you're going to get. And in this case, you are going to have a remainder 3. So what can you say about this? You know that the dividend equals the divisor times the quotient plus the remainder. In other words, you know that x cubed plus 2x squared plus 3x minus 7 equals x squared plus 4x plus 5 times x minus 2 plus 3. So again, the dividend, the divisor, the quotient, and the remainder. Now let's look at one thing that may seem that is actually obvious. Look at x minus 2 over here. If you equal this to 0, you'll have x equals 2, right? What happens if you substitute 2 into the whole polynomial? All of this is going to be 0, right? This is going to be 0. Multiplied by this, it is going to be 0. So what you are left with a remainder 3. Okay? So that's what it means over here. Substituting the value that zeros the divisor on the whole polynomial will yield just the remainder. So that is basically what the remainder theorem tells you. For a polynomial, whatever it is, P of B over A is the remainder when P of X is divided by AX minus B. See what this means. What is this B over A? Is the outcome of equaling this to 0, right? You'll get B over A. So if you substitute B over A on the whole polynomial, what are you left with? You are left with the result of this calculation. It's not going to be 0, it's going to be the remainder over here, as we saw before. Writing it in a different way, P of X, the polynomial, is going to be equal to the divisor times the quotient plus the remainder, which you can calculate immediately once you know the divisor. Just equal the divisor to 0, get the result of that, substitute that value of X on the polynomial, and you automatically know the remainder. We are going to see later with exercises how these two theorems can be applied to solve many different questions, namely exam questions.